Using instrumental satellite data on sea ice as a climate record. Hello and welcome. My name is Dante Sidoric, and today I will discuss how instrumental satellite data is a climate record, what climate data it provides, and how it has been used to reveal past climate change data about the Arctic and Canadian regions. This map shows the Arctic region relative to the oceans. For my script and slide references, I will be referring to sources 1 through 4. Reference 1 is the source at the top of the bibliography. Reference 2 is the source below it, and so on. For my image references, I will be referring to figures 1 through 6. Figure 1 is at the top of the image bibliography, figure 2 is the source below it, and so on. Instrumental satellite data helps climatologists understand how climate has changed and continues to change in the Arctic and Canadian regions by measuring and recording data on sea ice. Instrumental satellite data is a collection of evidence that documents the climate of the past. Climate record. An example of instrumental satellite data that this project will hone in on is sea ice. Sea ice is a climate record used to understand past, present, and future climate change in the Arctic and Canadian regions. Scientists interpret this climate record by looking at the subject of the instrumental satellite data, sea ice for example, and using it to understand a certain period of geologic time. This diagram shows where several different types of Arctic sea ice are likely to be found. According to NASA Earth Observatory, pack ice is floating sea ice that is not connected to the shoreline. The shoreline is a boundary between sea ice and land. A lead is a crack within the sea ice. Fast ice is a stable ice that is fastened to the coastline and is less susceptible to being moved by ocean currents. Scientists use changes in sea ice seen by instrumental satellite data over time, such as extent and thickness, to make predictions about future climate events. Scientists have built satellite sensors that can look at the microwaves emitted by sea ice and sea water to tell the two apart. Sea ice is a climate record because by observing it, we can deduce how the state of our climate compares to past climate. Now that you're familiar with instrumental satellite data on sea ice and know why it is a climate record, let's discuss current climate. Today, CO2 emissions, largely caused by humans, are heating up the Earth, causing a melting of sea ice. This map by the National Snow and Ice Data Center shows sea ice coverage in the Arctic and Canadian regions relative to the median sea ice coverage from 1981 through 2010, marked in orange. Sea ice works like a barrier to the sun for the water below. Sea ice has an albedo greater than that of water and therefore acts as a protective layer from the sun's rays. If sea ice melts, exposing liquid water to the sun will heat up the surface of the ocean more quickly, causing a positive feedback loop of even more melting. This phenomenon that I have described is exactly what we see when we study our instrumental satellite data on sea ice. When we think of sea ice, the first place most people often think of is the Arctic region. The graph titled Minimum September Arctic Sea Ice Extent shows sea ice coverage at the end of summer, the time of year when coverage or extent is the smallest. According to Scott Meakin and Catherine Hansen, climate trend of decreasing sea ice between 1980 and 2015 has been observed in the Arctic. According to Scott Meakin and Catherine Hansen, satellite data shows that throughout the whole of the Arctic, in every month, every season, the amount of Arctic sea ice covering the ocean's surface is smaller in 2025 than in 1985. The graph titled Arctic Ice Extent Anomaly shows the Arctic sea ice extent has changed over time using standard deviation to measure how far each year and each month is from the 1981 to 2010 baseline marked by the gray dotted line. According to the NASA Earth Observatory, Arctic sea ice extent has been decreasing consistently since 1985. Instrumental satellite data shows that this decrease in sea ice coverage is particularly significant during the summer months, according to Scott Meakin and Catherine Hansen, as well as the NASA Earth Observatory. Although they are geographically adjacent, the Arctic and Canadian regions have some distinct differences in terms of sea ice. This diagram shows global sea ice extent relative to particular geographic regions. Sea ice is comprised mostly of fresh water. When chemical bonds form crystals of ice called frazzle, their structures force out most of the salt. This increases the salinity of the surrounding water. Sea ice extent in the Canadian region is slightly less than sea ice extent in the Arctic region, suggesting that we can expect to find marginally higher salinity in the ocean water of the Arctic region than in the Canadian region. According to Leslerich, Halfar, Hetziger, Say, and more, These satellite observations and the corresponding data indicates that the decrease in sea ice extent is caused in part by greenhouse gas and aerosol emissions that humans significantly contribute to. Overall, sea ice makes the surrounding ocean water colder than it would be in a liquid state. That being the case, when sea ice melts, the surrounding water increases in temperature and decreases in salinity. This decrease in sea ice extent and corresponding increase in the ocean temperature is exactly what we see in the Canadian archipelago and Greater Canadian region. Conclusion. For both of the two regions focused on in this presentation, we observe an overall decrease in the amount of sea ice in oceans, according to NASA Earth Observatory. This is caused by a variety of factors, many of which, namely CO2 emissions, are only expected to get worse. Currently, sea ice is melting at a significant rate. As I have covered, sea ice melting starts a positive feedback loop of the surrounding water increasing in temperature, which in turn causes more melting, causing further temperature increase, and so on. Instrumental satellite data on sea ice leads us to believe that we should expect to see an increase in the temperature of Earth's oceans and a corresponding decrease in sea ice extent in the coming decades. We will see satellites like the GOES-R continue to monitor certain aspects of sea ice, such as extent and thickness, which will in turn continue to teach us about how our climate is changing. Therefore, instrumental satellite data on sea ice is a climate record. Based on the available instrumental satellite data on sea ice, humanity should reduce greenhouse gas emissions such as CO2 to reduce the rate of sea ice melting, both for altruistic reasons, such as to promote biodiversity, and practical reasons, such as to make the Earth a more habitable place for ourselves and future generations. Thank you.